Rod pumped wells are prime candidates for downhole video. We go down the back side in between the production tubing and the casing. And here's some of the first video of a perforation producing oil as the rod pump is going up and down. So each time the rod pump goes up, the oil squirts into the wellbore. Typically the week before they'll pull the rods and pull the tubing and take off the tubing anchor and recomplete the well without a tubing anchor and set the wellhead back on a dual wellhead or an offset type wellhead and let it produce like that for a week or so to clean up and maybe shut it in for a day even to clean up further, and then that next morning go in with downhole video down the back side in that annulus below the tubing, below the pump housing, and actually watch each perforation and see what's coming in. At these low flow rates, sometimes you can't see the water, it's so clear, but you can see the oil, and that's just as good. Here we have a rare example, in fact, my only example of annular flow, where the oil is flowing up the walls of the tubing. Kind of a thick oil and very vertical at this point in the wellbore, and so that's why this is rare. Although it looks like normal electric line, we actually have a fiber optic element hidden on the inside. That's how we get the crystal clear pictures back up to the surface. It's real time, but everything's being recorded for analysis later. Some of the units are packaged in offshore skids, and of course our best pictures come from wells that have gas or air or nitrogen in them. That's what we have here. This is a natural gas storage well. You can see the large fracture going up and down there. In fact, this fracture a few feet below got so big it was apparent that the drill bit was following the fracture for quite a ways. A few feet below here you'll see the open face of the fracture. If you look close, you can see the reflection, the crystalline reflections from the face of that fracture. And up at the top you can see back into the fracture a little ways. Here we have a basalt formation, a volcanic formation with very high fracture densities, fractures going everywhere. Basalt. This is one of our older cameras in which we had the light out front. We've learned it's better to light the whole situation from behind the camera now, so we don't do this anymore. Notice that not all boreholes are round. This is a typical characteristic shape indicating the direction of minimum horizontal stress, and you can tell the fracture direction would propagate upward right there. And you can see why it would be important to be aware of the shape of some boreholes when designing logging tools that have to follow the face of the borehole. Density tools can also be significantly affected by these borehole shapes. Here's a circular borehole, open hole, fracture going up and down. There is a formation up above us that's producing a little water, and that's what's dripping downward. A little pool of water in the bottom of the well here. Very large fracture, kind of a cave. Here we have, after a stimulation or frac job, you see the fracture going across the well bore. The customer was curious to see how much chemicals were left on the face of his well bore. Just found about 1.5 feet of particulates left there, which gave him confidence in that stimulation treatment. It wasn't hurting his well bore. Here we have a fracture going all the way across. This is an air drilled well, the top of the fracture, and there's some water being produced, maybe a little bit of oil. Here we have another fracture producing some fluid. Since it's real time, the operators often stop to see what's going on at a particular place. At this point, they found a gas entry point in which the gas is entering almost tangential to the wellbore and at a slight upward angle, and that's keeping the particles in kind of a permanent swirling pattern. Here's just a fracture going all the way across the wellbore from top to bottom with nothing being produced. Here we have two bedding boundaries of some sort with a fracture terminating at the bedding boundaries. Here we have some borehole breakout, which gives clues as to fracture propagation directions. Here's a washout, or a little cavelet. Did not give them any problem, but they stopped because it was interesting to look at. Here we have a casing on the bottom of your screen there. This customer had a very difficult workover. Come to find out, used downhole video to find out what was going on, and he had accidentally milled outside of the casing, then back into the casing, and back out of the casing again. You can see the boogered up edge of the casing, very shiny there. In fact, the bit down below here made quite a bit of new open hole, and the borehole got completely away from the original well bore. Here we have a whipstock. This is an intentional window. So there's the hard face of the whipstock. You can see the little iron filings on the edge of that whipstock. Up above you can see the casing where they've milled through it. As you get deeper and deeper, and the hard-faced ramp gets you further away from the center of the original well bore, you can see where the mill is cut through the casing and the cement, and you can see the formation. So you can see all the levels: the whipstock, the gap, the casing, the cement, and the formation. And this is what a casing window is supposed to look like. The next customer was performing the same operation when something went wrong. You can see up the top where he started the mill job, but the whipstock has turned 90 degrees right in the middle of the job, causing him a lot of difficulties. If you set the whipstock in an unconsolidated formation, this is what it looks like. Just a black hole. Here we have a bridge plug that's leaking. You can see oil being produced from below the bridge plug. In fact, the only oil being produced from this well was from below the bridge plug. In this section of open hole, you can see some fool's gold, or iron pyrite crystals, or nodules, in some sort of matrix that's been partially eroded away or dissolved away. And although this might look like open hole, this is actually cased hole. This is a producer in a water flood area, a calcium carbonate scale that's filled up a significant portion of the casing. They went on down to see exactly where the oil was coming from. Here we have oil being produced not from these perforations, but from below the sand. And here we have a piece of corroded casing. It was interesting because this was the only piece of corroded casing in the whole string. Apparently it was a different metallurgy than the rest of the casing. It was acting as the sacrificial anode for the whole string. Here's another form of preferential corrosion along a seam at the bottom left of the screen. And here we have casing that's been almost completely corroded away. You see the bottom right hand quadrant of the screen where you can actually see out into the cement and formation. The casing's very thin. Some customers are using this in oil fields before they buy them to get an idea of the liabilities they may be buying into, or to help negotiate prices. This customer thought they might have collapsed casing. Come to find out they've just got mineral deposits, and the solution was obvious. You used coil tubing with some acid and you washed it right out. This customer had the same symptoms but actually had collapsed casing. You can see how the casing's been kind of collapsed up into a ribbon. Sometimes we give good news and sometimes we give bad news. Here we have casing that's been shifted to the side. This was a normal production logging run, but found a rip in the casing here. Sometimes we find things we're just not expecting, such as this piece of trash hung on a collar. Knock that down whole, no extra charge. So as you've seen, we're finding solutions with downhole video. That's the way to look at it. And that concludes this little informal sampling of examples.